Well, good afternoon, good evening, or good morning, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a great webinar on tap today with some really interesting information, but before we do, we have a few housekeeping items. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it on demand later on. We will be sending out an email after the event that includes a link to access the webinar. And we are taking questions from the audience. So if at any time during today's presentation you have a question, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll take a few minutes near the end of the presentation and go through the audience questions. And also at the end of today's presentation, we are going to be hosting a drawing for 5 $50 Amazon gift cards. So stick around until the end of the presentation, and hopefully your name will be one of the 5 drawn. Okay, with that, we will kick off today's webinar, which is Kubernetes Pipelines. Hello, New World. Our speaker today is no stranger to the DevOps.com webinars. It's Tracy Regan, who is CEO of DeployHub. Hi, Tracy, how are you?
Hello, I'm great. Thank you.
Great. Well, I'm going to put myself on mute and let you get right to your presentation.
All right. Well, thank you, Charlene, for that intro, and thank you to DevOps.com for holding this webinar. I am sure this is not the first webinar we'll be hearing on Kubernetes and Kubernetes pipelines. This is pretty much a new world, and there's some changes. I am going to cover 4 primary, what I call the pipeline challenges when it comes to Kubernetes. That's what we're going to be covering today, just so we can start a conversation about what microservices and Kubernetes are doing to our standard CI/CD process. So as Charlene indicated, I am Tracy Regan. I am CEO of a company called DeployHub. DeployHub is a microservice sharing and mapping platform that also does deployments of your microservices. I've been doing DevOps long before it was even coined a term. We used to call it ALM and lifecycle management and configuration management. I've been doing this for a while, since 1980s, when I was working on Wall Street and looking at the problems that we're having on the distributed platform, or what they called open systems at the time, and started building out solutions for automating software builds and deploys. That brought me to a new spot in my career. Started a company called OpenMake Software and a product called Meister that managed build automation for highly audited environments. And I co-founded DeployHub last year. Will be a year old next month. And I did sit on the Eclipse Foundation for some time, so I've got some background in the open source world. So just to get started, I want to define what continuous delivery is, because I still have conversations where this term is confused with continuous deploy. There is a new CD Foundation that is it's under the umbrella of the Linux Foundation. DeployHub was a founding member, and I thought that their definition of continuous delivery was worth going over. So in their definition, CD is a software engineering approach in which teams produce software in short cycles, ensuring that the software can be reliably released at any time. It does not do software compiles or builds, it doesn't do testing, and it doesn't do deployments. It is a process of managing or orchestrating the application lifecycle. Maybe a better term should have been continuous lifecycle. So in today's sort of common development practice, what we see is a process where software applications are compiled as a package and they're released as a package. And there's this sort of a waterfall heartbeat where you have a dev state, test state, and production state. And an application package is moved with everything in it across those the life cycle. And oftentimes it's not decomposed. Everything, if even a minor change is made, you recompile everything and you re-release everything as a full package. This practice is going to go away, and we'll be talking a bit about that. So the other thing to think about in terms of what we see right now in terms of a continuous delivery workflow is a continuous delivery workflow is built around a release, meaning a version of an application. You know, your teller application version 10.2. And a release is compiled and deployed as a single monolithic package. Now, it can be deployed by a continuous deployment tool or a script to different environments, and those environments may be mixed. They may be physical server still, or a cloud image, or even a container. And in some CD implementations, a new workflow is defined for every full release, and then a point release is a new version number is applied to it, which is represented by a build job number. So that's sort of how we keep track of the application, or what I like to call the monolithic package. So we do still have a waterfall in this. We still have a dev test prod, kind of a heartbeat to it. I've never seen anything else, and we don't really have any other options. We have a physical environment that forces us to have this waterfall approach. So monolithic builds and releases end up being waterfall, and part of the reason why your deployments are monolithic is because your builds are monolithic. It all sort of fits in together, and it fits quite nicely. And we kind of figured this out, and we've been rolling along here, but now microservices is changing everything. We are going to pretty much obliterate the waterfall, and the environments are going to be changed, and our CD practice is going to change. So the moral of this story is keep an open mind, because there's going to be some work to do in defining how this new environment fits into the CI/CD process, or what I like to call a Kubernetes pipeline. So just to make sure we're all on the same page, I'm just going to go quickly through these pieces. If you think of what Kubernetes is, it's an open source platform written by Google, and it manages, it does basically container orchestration, or manages clusters of containers or servers. The containers, everybody's probably heard of Docker. It's a kind of a standard unit of a software package where you put all your dependency in it and you can run it. It's like the new installer. And then a microservice sort of sits on top of all of that. A microservice is installed into a container, and it is a small, or it's an architectural style that structures an application as a collection of loosely coupled services. What I want you to think about is think functions, and think functions that are independently deployable. It's really it's a new way of doing object-oriented programming, or you can think of it as a different way of doing service-oriented architecture, but it's definitely a function-based model. When you think functions, Chris Richardson has written quite a bit out on microservices.io, which I highly recommend you take a look at. And he talks about microservices and what they are and how they should be managed. First of all, he talks about a service should implement a small set of strongly related functions, and a small set is key. And services that change together should be packaged together. So let's say you have a security team and they have a set of services. That's their application. And the services can be changed without affecting clients. So services should always be backward compatible, which is a tough one to achieve and may not be always realistic. And then each team owns one or more services, and they must be deployed in an autonomous way. So you have to be able to develop and deploy a service with minimal collaboration with other teams. So we're really moving into this think function kind of mentality. So let's think about the first challenge here that microservices and this new Kubernetes pipeline brings to us. And that has to do with repositories and workflows. So right now we have an application, and an application is in a single repository, and your CI/CD process has a workflow for that application. And it's generally all the pieces that the development teams are managing. So it could be one big fat WAR file, or a fat jar file, or a collection of jar files, and maybe some other scripts that define some environment variables and some other pieces and parts that they pull together to create their application. Well, because microservices are independently deployable, they're probably going to need their own repository and workflow. So if you think about what that might look like, instead of one workflow per release, you're going to have many workflows and many releases. So in using our kind of our waterfall model on top of a new function model, instead of having a full application package, you'll have a function that goes through a dev, test, prod lifecycle. And when you break apart an application and decompose it into microservices, you're probably going to start having to ask yourself how many workflows might you have to manage in your CI/CD process. If there's many of them, this could be quite a headache to do. And in terms of how you define your CI/CD engine, like a Jenkins or a Circle CI, and how you manage those workflows, there's different settings that need to be applied to better control those workflows. The other thing is that we lose our monolithic application. So if we have a new service kind of architecture whereby we're writing functions and we're reusing other functions from other teams, and we have functions that are related to our application-specific functions, how do you keep track of the application, the monolithic equivalent? So there has to be a way to map the microservices to the applications that consume them. This is going to be critical because what you're really doing in the CI/CD process is you're managing the lifecycle of an application, not a single microservice. And now you're going to have multiple microservices that make up your application. So these two areas, the multiple repositories, the multiple workflows, and being able to aggregate that information down to an application version becomes a challenge. Okay, challenge number 2, environments. We really are going to be moving away from this concept of dev environments, test environments, and production environments. This waterfall concept is finally going to go away. We talk about agile and moving away from waterfall practices, but our environments, and in many ways the way we see things, is still based on a dev, test, and prod structure. That with Kubernetes will eventually go away. Now, in what I call the first phase, which is where we see many companies who are really embracing a microservices architecture, they start here, where they have a different cluster that one represents dev, one represents test, and one represents prod. This is sort of a nightmare to keep track of, because remember, you're not managing a package, you're managing lots of moving pieces and parts that make up a monolithic equivalent, but you're not actually managing them. You're managing at the microservice level. But having these these clusters that represent our monolithic environments is where most organizations start the process. And that's a good place to start, because the tools aren't necessarily fully baked yet, but what's coming, if we look around the corner, if we look down the street, we look around the corner, we're adding something called service mesh. And service mesh is what takes the waterfall process and finally gets rid of it. So service mesh, there's a couple of them. There's one called Istio. Istio just got funded. They got some of the guys who support it started a company called T-Rate, I think, and now it's escaped me, but they just announced they got about 12 million in funding, which means that we're off and running on the service mesh level. There's something that the Cloud Native Computing Foundation manages called Linkerd. But what you can think of as service mesh at the first layer is when you let's go back to compiling code. When you build your monolithic application, you're compiling your components. you have a link step. In the jar world, you're jarring up files, say. And the C world, you're doing a link. And you do that at the build step long before the release. In Kubernetes, Service Mesh basically does that. So you have all of these different microservices. Service Mesh does that linking. It also will replace this concept of environments, because what it has the potential to do is be a request router as well. And that can be done depending on a user profile. So what happens is when a user logs onto the UI based on their user profile, the service mesh can route them to a particular version of your application that is made up of particular versions of microservices. Now, it could be that just one microservice has changed, creating a new version of the application, which means that a developer could be running tests against everything at what we would consider the production level, with one change at the development level. So deployments aren't going to be dev, test, and prod anymore. You're going to basically publish a microservice out to the cluster, and the service mesh is going to do the request routing depending upon the user profile. So this service mesh piece really does change the way we see and write, or I should say we see and manage our CI/CD pipeline. Challenge 3. So now that we have sort of decomposed our monolithic application, we have to have a way to track it. So mapping and versioning the microservices and the applications that consume them is another area that we'll have to fix in this new Kubernetes pipeline. It's basically, we need to be able to do really good dependency and version mapping. So we can always understand if a group of users that we call production are using a particular version of an application, we can map what microservices they're consuming, because it's not going to be in the same way as we had it before. So if we think about what that looks like, it's all about creating a logical view. It's no longer a physical package, it's a logical view of an application. So the Kubernetes pipeline will need to provide some level of mapping and versioning to represent that logical view. It's important to remember the monolithic application still exists. It's just represented by a collection of these microservices. And then a new microservice creates a new version of your application. So when you make an incremental update to a microservice, which really is just putting a new microservice out there, and you have now a new collection of microservices creating a new application. So this is a really incremental process. It's no longer monolithic. You change one little thing and a group of users could all be using version 1 of the microservices. You put a version 2 and just the dev or test teams are using that configuration of the application. So Service Mesh will be used to do that, to route those application versions to different users, and that's what really requires a new way of thinking about things. And then we have to think about, we have to go back to what a microservice is. It's living inside a container, which means that we have a lot more servers out there. Instead of having, I don't know, let's say you manage an application that requires 1,000 servers. When you break it up into microservices and containers, you might have 10,000 of them. And each one of them has their own kind of configuration pieces, or what I like to call attributes, like AWS Lambda specifications, or Helm chart installation logic, or you might be using an Ansible Galaxy role or a Red Hat operator, or you might just be defining those configurations in some kind of a file. Those configurations need to be tracked as well. So it's not just the microservice, but the logic that's installed with the microservice. So for example, operators define how a particular container should interact with a Kubernetes cluster. So if these configurations aren't tracked, it can become problematic because they can cause issues. And these issues can be really hard to detect. So there's going to have to be a way to do comparisons between the configurations for a microservice as well as the microservice itself. So when suddenly there's a degradation in the performance of your application and you're not sure why, you have a way to do comparisons. So we are really going down a road that says this is truly configuration as code. And how do you map it? How do you version it? How do you compare it? And then there's the finding and sharing problem. If we go back to our object-oriented programming days, what we would have learned was that we were not set up at the build side of the puzzle to be able to share libraries in a really impactful way. So what was happening is developers would copy shared components or shared objects, and maybe they put them in their own repository, then they check them out into their own build directory and they compile with those. So they became copied code, they weren't shared. And then there would be a wobble, they would change so then they had to start using versioning of those shared libraries, which is what basically Microsoft did. They started putting the version name and for the name of a DLL in order to avoid these kinds of problems. We don't want to do that with microservices. We'll have thousands of crazy microservices running out there, and we will have a failed microservice implementation. So if you think about what's happening right now as companies move down this path to microservices, is the architecture is becoming what I call a tangled hairball, and the microservices are kind of unknown and disconnected. Not only that, organizations are still siloed. Somebody on the 4th floor could publish a microservice for doing standard error logging, but somebody on the 8th floor would never know that microservice exists, so then they go write their own. So part of the Kubernetes pipeline will require the ability to catalog and share microservices. Now, there's quite a bit written on this topic, and I would again refer you back to the microservices.io website because there's quite a bit discussed on it. But the basic concept is you use what we call a domain-driven design to organize your microservices because you need developers to find them. Think about using a music sharing service without the ability to find or organize the music based on an album or an artist or a genre or a new release. It would kind of be a pain in the butt to try to find something. That's basically what's happening with our microservices right now, because without a tool to do that domain-driven design of some sort, you could probably put it in an Excel spreadsheet, but you can see how this can get out of hand pretty quickly. So our Kubernetes pipelines are going to need to start thinking about how to manage the cataloging and publishing of these microservices. If the goal is to have continuous delivery is to always to move an application across the life cycle as quickly as possible, and that it should be repeatable and readily available, then part of that solving that problem in Kubernetes will be to figure out how to manage all these microservices in that domain-driven design. So I really recommend taking a look at some of these articles written around DDD and how they apply to microservices, because it's pretty fascinating and it really defines how you should be thinking about your architecture, and it really will define how you think about building out your CI/CD process, or now we'll just call it a CD process. So in conclusion, let's just go through those 4 challenges again. We're going to continue to have some sort of a continuous delivery workflow process where you're going to have a CD engine that pushes the workflow to publish a microservice, potentially publish it, then deploy it, run some route to the right user, run test. So that kind of workflow will still exist. It's just going to look very different. First of all, a few workflows and repositories we're going to change to potentially hundreds. You literally could have hundreds of workflows out there. Microservice configuration mapping will bring the collection of microservices or aggregate the collection of microservices to your monolithic equivalent. And as part of that mapping, you're going to need to track the configurations of each of those little mini servers called containers, and that's associated to every single microservice. Your waterfall environment will become a single environment. No more dev, test, prod. Instead, you'll have personas that the service mesh will route those people to those particular spots. And then finally, you're going to have a way for your teams to catalog and share those microservices, and that cataloging and sharing should become part of your CD process. So I know I've gone through quite a bit, but I want to, these 4 topics I think should really drive some of your future conversations about building out a pipeline process to support this modern architecture. The better we do at understanding the challenges around managing the microservices, the easier it will be to begin using them. And there's real solid reasons for moving to a Kubernetes microservice environment. Fault tolerance and scalability are things that are 2 functional areas on the operations side of the house that we have struggled to achieve for years and years. This modern architecture does it automatically. And microservices makes it super, super efficient. And if you're building out machine learning or doing any kind of AI applications, which most of you will be doing in the future, it's this type of an architecture that will be required to really leverage the processing power and be able to spin up 40,000 microservice, one small little function to do some sort of pattern matching, and then dump it all down to 1 or 2 pods. That's the kind of processing power that you're going to need in the future, and that's what these microservices do. And on that, just a word from our sponsor, which is DeployHub. So DeployHub has an open source project called Artilius. Would love for you to take a look at it. It's specific to microservice configuration, mapping, and sharing. That has been recompiled and put out on a Google in the Google Compute environment, and there's a team version of it called DeployHub Team that's in a SaaS offering, and it's free. And then some more information. I've put my information out there to follow me on my Twitter and LinkedIn. I do publish blogs on this topic on a fairly regular basis. You can go to DeployHub or Artilius or microservices.io to learn more. The Linux Foundation and CNCF is pretty important too. And on that, I will take some questions.
All right, great. We have gotten a ton of questions in so far, so let's just dive right on in. First question, let's see. Can you share some best practices on version control on microservices?
Yeah, so that's a loaded question, isn't it?
Yeah, right.
So a couple of best practices. Number one, it's going to look different than what version control is for like checking in and checking out source code. There's quite a bit of conversations around this concept of GitOps, which is basically what we're talking about. And what I've seen with the GitOps kind of approach is that you pull together your monolithic equivalent that defines all your microservices in a single script, and then you check that script in. So that is one way of versioning your microservice configurations. Now, some of the things that we lose in that is we lose the flexibility of only having one per microservice. And that's probably the best way of moving forward in the future, because you can't make an assumption, because what you want to be able to do is, number one, you want to be able to track what a microservice, who's consuming your microservice. Number two, you need to track where the microservice is being stored. So most microservices are going to be put in some sort of a repository like a Quay or a Docker Hub or some other, something from Red Hat or IBM, where you might have a private repository where you store your microservices first. It's like a repository for binaries. And your version engine should be able to point to and say, this is where it's coming from. The versioning tool itself doesn't need to become a repository. It just needs to be a pointer. And then the third best practice is to make sure that the what you're versioning is not just the microservice, but the configuration of the container that the microservice is going to be running in. So you sort of need that. You need the dependency management. You need to point to where the microservice is being, the repository that it's being stored in, and you need to understand what the configurations were that installed it. So at the risk of taking too much time to answer that question, I'm going to leave it at those 3 best practices.
Okay, great. Next question. I would like to know why I have to map the versioning from microservices to an overall application, since they are loosely coupled and completely not dependent from each other.
That's true. They're loosely coupled. They're not dependent from each other, but you're going to need to know if you're running in something in production, what a user's using if there's a problem. And that's the best way to describe it. So we don't want to throw away the monolithic equivalent. If you're a bank and you've got a teller application and that teller application's got 300 loosely coupled microservices and you have a bug in production, the production user are having an issue. You need to know what microservice that they're using, what that monolithic equivalent looks like. Otherwise, you're going to struggle with being able to quickly fix the problem. So if you're not able to see what the version of the application is that they're using, you're just down to what the microservice is, and if you have no way of understanding that microservice interaction with another microservice, it's just going to make it extremely difficult to start debugging some of the stuff. It's making it simpler.
Okay, awesome. All right, next question. Are service meshes, easy for me to say, Istio or Linkerd, being used in production currently and at scale?
You know, this is a great question because that was a question that was asked at the Open Source Leadership Summit. And based on the information that's coming back from the CNCF, we're about 5% of the companies are starting to use service mesh. So service mesh is very early in its implementation, and the folks that are willing to be on the bleeding edge are there.
Okay, great. Next question. Let's see. What are your thoughts about how data management will have to evolve given this Kubernetes pipeline, especially when persistent data is required?
Yeah, that's a whole presentation in its own, right?
Right.
So first of all, there's challenges around even understanding where. Again, if we go back to the monolithic equivalent, we need to know what version of the database that those microservices that need to hit a database are hitting. When you add service mesh in there, you're going to have to have a application that is hitting the test version of those databases. So I really can't go into all of the problems that are foreseen when managing data in these environments. But what I can tell you is that including the database management pieces, the components, as a microservice that can be independently managed and then map back to a particular version of an application will be critical, so that when service mesh starts routing people, a developer, a test, to a particular version of the application, it's using the correct version of the database. And obviously you can't roll back. Well, I guess you can. It depends on what the database change is. If you roll back something, if you have to, which you might, or take something away, basically in the Kubernetes world, you would move somebody off of a microservice that's hitting a certain version of a production database, and move them off of that, and you risk losing data. So in essence, we're really not going to be thinking about rollbacks as much as we are roll forwards or jumping forward.
All right, great. Next question. Let's see, would this complement ringed deployments or is it a replacement?
What kind of deployments?
Ringed, R-I-N-G-E-D.
Ringed deployments. That's not a term I am familiar with. Okay. So I will not be able to answer what a ringed deployment is.
Okay, well, maybe Dave can send me a clarification. Okay.
I'm a quick study, so I probably could answer if I understood what ringed means.
Okay, great. So you did have another question though. So will the service mesh manage dependencies between microservices?
No. Well, service mesh will not, but the file that you pass service mesh does. So service mesh is going to expect something to be passed to it. It's basically a file that says what the monolithic equivalent looks like.
All right, great. Next question, how to apply changes to underlying infrastructure and platforms, say Kubernetes and its VMs, external load balances,
Yeah, so
etc.
those tools, that's where most of the money is being spent right now in the Kubernetes world. Products like Rancher, and there's a whole host of products that are managing the Kubernetes structure itself. And in my presentation, I did not talk about how to manage the Kubernetes environment itself. But there are tools out there. There's been quite a bit of investment right now. When you look at, if you went to KubeCon and you wandered through the hallways of all of these new tools out there, I would say 80% of them are automating the management of Kubernetes itself. I think Rancher has gotten the most attention, and I've looked at their tools and talked to those folks, and some of that stuff is pretty cool what they're doing for
Okay,
managing at that level. And what we talked about today is really sitting on top of all that and managing at the application level, which will be as challenging as managing the Kubernetes structure itself.
excellent. All right, great. Well, let's see. As I said before, we have a ton of questions. So next one, is the complexity growing out of hand compared to the benefits here? What are the fundamental drivers that will make this complexity, quote unquote, worth it?
Yeah, so the two big driver, well, let's call them three. The big driver is AI and machine learning. Um, I, the first time I ever saw a microservice application is a company that they basically create virtual images of DNA structures. They have a database of all these DNA structures for pharmaceutical companies.
Hmm.
And if somebody wants if they're going to create a new compound, they need to see if it's been patented. And so they provide an image of that DNA structure, and the tool has to go out and go through all of these images and try to map it to see if it's infringing on somebody's patent. Before, it would take literally, by hand, could take months. And with the old solution, it could take quite a bit of time to crank through all of this stuff. When they put it out on a microservices kind of a Kubernetes environment, and they were able to spin up graphical processing units, you watched what that application would do, and it would spin up. Went from using like 10 GPUs of their pattern matching to 40,000 in seconds, and then once it found the match, it dropped them all. You can't do that with a traditional architecture. When you're talking about like self-driving cars, fault tolerance is kind of important. You have to have something that can repair itself, and the availability of services when you need it. So the ability to auto scale. This is what's driving it. The complexity is a problem right now. It really, really is. But we're really early in the market. Like I was pointing out, Istio just got funded at a whopping $12 million. I've heard, ARA tools being funded at higher levels. So we're new. We really are just coming out of kindergarten for a lot of this stuff. There are companies who are using it to build out really amazing AI and machine learning, or even Google themselves. I met with a woman who was one of the engineers for Google Docs, and she talked about how that looked. And the number of microservices and how they managed them and spin them up, and the problem that they had with managing the configurations of the versions that they were trying to track of the monolithic equivalent, and how that was being maintained pretty much in one person's head. And they have this concept of a haunted graveyard that are clusters of microservices that they don't know what they're doing anymore. There is definitely a problem with complexity. But as there's money invested in it, and as companies start using it, tools will be written and to improve the environment in the same way as they were when PCs started, and we went from mainframe to PCs and had to build out all different types of new tools to manage networks. We're going to see that kind of investment in Kubernetes. So it may not be worth it now, but we'll get there.
Okay, great. All right, next question. We will try to use containers for our applications, as that will make life easier when we want to scale. Also, we'll be able to gather performance statistics on each container individually, and logging would be separated by the container as well. I think it would be easier for us to manage the solution in the future, as each microservice would be its own container. What are your thoughts?
I think that starting out using containers as kind of they were initially intended, where you install, like for example, if you wanted to download our Deploy Hub Team or Pro product and you wanted it to be on premise, you could go to the Red Hat certified container, you could go to Quay and you could download our container, and all the dependencies are in there. And if you needed to have more containers, you can have more containers. Right now, that's for most companies. If you're there, you're farther along than a lot of companies. But as you get experienced with containers, what you just said, being able to take some of the logging, so you start slowly decomposing your monolithic equivalent in that massive container to multiple microservices. I would say go for it, but start thinking about ways to manage them, and don't get too big too fast. Stay small and keep it simple in the beginning. And you'll learn what you have to do to your CI/CD process, what I would like to call your Kubernetes pipeline process, to start carefully tracking those microservices. And Excel spreadsheets will work in the beginning, and you'll need to do something like that. But as you grow, you're going to have to move to tooling.
Okay, all right, great. Okay, here's an interesting one. We are a financial services company with very secure data and access. As such, we maintain different environments as a security control. How would this play with separate Kubernetes in different environments?
So you're probably going to do what I had this. Let me see if I can quickly go up to this. You will probably want to build this. Now, that doesn't mean you won't have service mesh in there doing some request routing, but you will probably do this. And things like model office will still be a conversation with, the highly audited fintech, government, securities, insurance. And this may be what it looks like for them, where you have these different clusters that define your dev, test, and prod environments. And that's totally okay. You just have three you complicate things by having that many more services to manage. You got 3 times instead of just one. But I believe that's where you'll start. And as service mesh becomes more mature and more intelligent and does a better job of the request routing and interface with things like LDAP, you'll move off of it and you'll go to that. I think that will be that's going to be what your roadmap looks like.
All right, great. Let's see. Next question. Are databases considered as environments, components to manage with service mesh?
No. So a database should be a database is going to sit out there, and you may have multiple versions. You may have a dev test database, and you're going to have microservices that connect to those different databases. So you may have just one big database component or microservice, or it doesn't really matter what it's called, but you'll have a piece that is a database piece that will route your microservices will route to.
Okay, let's see. Next question. Could you provide?
Let me make sure. So what's going to happen is when you log into the UI, that's going to pretty much define where your database is going to be connected to.
All right. Sorry about that. if I went in
Okay.
too early. Okay, next question. Could you provide some examples of configuration as code in this new schema to resolve dependency and version mapping?
Can I provide some examples of configuration as code? I'm not sure how to do that. So let's just break it down into its individual pieces. Let's just think about configuration as code for one microservice. When I talked about the GitOps folks and sort of where they're going with what they're doing is they see that the configuration layer and for the most part, configuration as code didn't talk about the application layer. It talked about the infrastructure layer and how you're defining your configuration of your infrastructure. That will still be a separate piece from managing the container, because now you have two pieces, right? So each container has its own configuration to talk to the Kubernetes layer. So you can have configuration as code at the operations or the data center level that manages the Kubernetes environment itself. Changes on that level would be the speed of how quickly something gets spinned up, how it gets spinned up. There's tons of specifications. If you look at like AWS Lambda and look at the specifications that one function, if you write a piece of code and you call it a function, and all the specifications there are to map that function and have it how it operates in that Kubernetes cluster. So that's a good place to start to understand what kind of specifications would be managed at the microservice level that I'm calling now the microservices configuration as code. So you have two levels. You have the higher level that is how that microservice interacts with the Kubernetes environment, and then you have other configuration as code that the operations side of the house that's managed, that are using tools like Prometheus and Rancher to take a look at how those configurations are being managed. In either case, it's important to be able to track them. So the GitOps folks are talking about being able to pull them out and pull that information into a file and then check that file in so over time you can see the differences. So the goal is to be able to compare between two installs or two configurations, so it's easier to sort out a problem when it arises. Remember, we don't have a whole lot of tools in this environment yet, so any way that we can track the changes that are being made at the operations level, at the Kubernetes level, or at the container that's trying to talk to the Kubernetes level, and that's where the problems are going to show up. So you have to have a way to track that. I don't think I answered that in a really great way, but that's the best way. Those are kind of the best examples. And really, it's enlightening just to go look up AWS Lambda and look at the specifications. It gives you an idea of the number of parameters that a microservice or a function could use to talk to Kubernetes. And that's what things like Helm are doing. Helm charts, operators, the goal is to make this a little simpler.
Okay. Well, it sounded great to me. So moving rapidly along here. Let's see. Today, the configuration more important than the code when there are many moving pipelines. What best practices do you suggest to elegantly containerize and manage them? And then should each microservice be delivered as independent entities?
That's the goal. The goal is to have each microservice independently deployable. If you look at some of the blogs on this topic, and even if you look at the domain-driven design, there's some interesting conversations going on about this, because let's say we break down those microservices into functional areas. And your bank, it's a teller application, so you have some pieces of that application is the front end, some pieces are off the back end, do some sort of daily reconciliation. What some of those blogs are talking about is basically having these mini kind of mini applications or sub applications. So all the microservices related to doing the reconciliation process, there may be, 100 of them, become their own releasable unit, and you push all those out. When you update those, it's sort of more of a monolithic. That's one conversation that's being had to try to solve some of the problems like backward compatibility, because at least you know that all of the microservices in that collection are healthy together, and that's where they're most important. And so their connections can remain backward compatible. So their connection to the UI remains backward compatible, even though their discussion in between them may not be backward compatible. So you have to release more than one microservice as a complete unit. So we may have another level in here in this domain-driven design where you have a collection of domains that end up making up an application.
Okay.
Or are critical pieces. Read that question again to me. There was another part of it in the beginning.
Okay, let me get back to it here. Sorry, let me, no. Today the configuration. Okay, today the configuration is more important than the code when there are many moving pipelines. What best practices do you suggest to elegantly containerize and manage them?
I don't think I have any.
That whole best practices question.
Yeah, I don't think I have any
Yeah.
right now.
Okay.
Other than the 4 challenges that I talked about, I think that's where you have to start, is to begin understanding how you can start relating the microservices and understanding who's consuming them. I think that's going to be more critical. Everybody doesn't want to have a haunted graveyard. So, and the reason why you would have a haunted graveyard is because you have microservices out there that you're not really sure if somebody's using or not. And then somebody's using it, but you don't know which application's using it to get them off of it. And as this grows, what I believe is going to happen is we're going to have more machine learning about these microservices, right? So we're going to be able to use service mesh and say, hey, can you tell me if anybody's connected to that, and who that group is, or who that user is, or what that application is using it. And so I wouldn't say our best practices have really been solidified yet, because the platform is still fairly green, even though microservices and containers themselves have matured quite a bit. Kubernetes is now graduated. It's no longer being incubated; it's graduated. There are tools around it that are going to solve the problems that you're asking the question about. They may not be here yet, though.
All right, great. We have about 8 minutes to the top of the hour, so I think we have time for 1 or 2 more questions. Okay, so here's one. Do you have any ideas on how to handle service-to-service API compatibility? If a service changes its API and you make a version 2 for it, how do you manage to indicate version 1 is a deprecated API?
That is exactly the problem.
There we go.
That is one of the problems. And your service mesh can help solve that, because you're going to tell service mesh by a file that you need to deprecate that, or you're actually just leaving that one out there as a maverick. It's just an orphaned microservice, because you may not know who else is using it, and you're pushing them to another microservice. So that's a conversation that I hear a lot of folks talking about, is how do you do that? How do you deprecate that? I don't have an answer for you. I'm very sorry. There's probably a lot of smart people out there that has dealt with this that probably can, but it's not something I've had to deal with.
Okay. All right. Move on to the next question then. Let's see. It's actually more of a statement. I don't see how you can not get out of dev test production with what you are describing as problems in production, since you must test independent from dev to put into production.
Yeah, so so we have you may have this. This is how you might start, where you have a dev cluster, test cluster, and prod cluster, and everything looks very similar to the way the environments are running today. then you're going to start seeing a shift to this service mesh. And the service mesh is, you pass to service mesh at the time of this, the person logs onto the UI. That UI then determines, based on a user profile, the collection of microservices that they're using. And it may even push them to microservices that are connecting them to a dev database instead of hitting the production database. So it's the service mesh that's going to become that critical piece that's going to do the request routing. And once that service mesh starts doing proper request routing, especially if you're using something like an LDAP, that's going to help you define those user groups, then you will be able to do testing, and you'll be at a true incremental sort of agile practice. Because in the agile world, what we've always said was, hey, if you're just changing one piece, you need to be able to make small incremental changes and release them on a daily basis. What we do is we make a small incremental change, we recompile everything, and we re-release everything. In the microservices world, you're going to make a single incremental change to a microservice, and you're going to update that microservice to your cluster. And it's going to be your service mesh is you're going to pass it a file that says these are the service meshes this is the microservices that we want service mesh to route us to for this particular user profile or this group of users, and they are now testing, or they are now doing their development, or they're doing model office. That's just how that's just where we're headed. That's the diversion that this type of technology is providing us.
Okay.
And you'll manage that based on pods and clusters. So the more you learn about how Kubernetes looks and how it's organized, you'll start understanding how you could have a cluster out there of microservices that is a new version, and that's getting used instead of another cluster of microservices.
All right, well, we are about 3 minutes to the top of the hour, so at this point I'm going to close out the question and answer period, and I do want to thank everybody who did submit questions. If we didn't get to your question, just know that the folks at Deploy Hub will be getting a copy of all the questions. So,
and I will be happy to send it to the guys who are a pay grade higher than me to answer that, especially the API one. That's a really interesting one.
Yeah.
And I want to thank you all for the very, very challenging questions, because every time and I wish it was more of a dialogue that we could be having instead of a monologue, because this is how we solve these problems, is by asking these questions and chewing on them and starting to. That's the only way we're going to start finding answers.
Yeah, well, it's definitely some good questions today. So yes, thank you to everybody who did submit questions. And I promised at the top of the hour that we would be doing a drawing for 5 $50 Amazon gift cards. So let's go ahead and do that real quick before we close things out. So let's see, drum roll please. Our first Amazon gift card winner is Angel Nunez. Congratulations, Angel. Our next winner is Ricardo Garcia. Congratulations, Ricardo. And our third winner is Dave Kelly. Congratulations, Dave. And fourth question, questions. I'm on questions now. Fourth winner is James Griffin. Congratulations, James. And our last winner for today is Kelly Crick. Congratulations, Kelly. Congratulations to everybody who did win today's Amazon gift cards. If you were not a winner, then tune into a future DevOps.com webinar. Hopefully you'll be a winner at that one. I do want to remind the audience also that today's event has been recorded. So if you missed any or all of the event, you will be able to access it on demand. We will be sending out an email that contains a link to access the webinar. The webinar is also going to be on the DevOps.com website, so you can always look for it there. Just go to DevOps.com/webinars, and it should be right there waiting for you in the on-demand section. And while you're there, please check out the other webinars that we have both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Tracy, thanks for such a great presentation and for answering so many of those questions today. I was stunned at the number of questions that we had in and the quality of them. So I know folks got a lot out of your presentation.
Well, thank you. Thank you very much. And thank you for everybody for attending. I appreciate it.
Yes, everybody. Thank you for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.